Good evening, everyone. I think in the last video, we are talking about a circular single linked list, right? Yeah, very good evening. So, circular single linked list. So, in that, I explained very clearly how we can able to add the elements. Okay, how to represent this circular single linked list. So, next and after that, how to add the, how to print the values. And even we have discussed how to add at the beginning. So, how to add at the ending, even how to add at a specific position also we have seen very clearly with the example program in the last videos. Okay, now in today's session I want to talk about the deletions, sir. Okay, I want to talk about the deletion. Sir, suppose consider I have linked list like this. Okay, so consider I have linked list like this. So list dot add tail of, so I want to add 5. Okay, next list dot add tail of, so I want to add 6. Like this we have some elements are there. Since it is a circular linked list, so 1 2 3 4, next and after that 5, next and after that 6, like this we have. Let's execute up to this. So you can able to see we have 1 2 3 4 5 6 are there. Now my requirement is I want to write a function to remove the element. Sir, which function we need to take? So void, okay, remove head. That means what? I need to remove the first element. How to write code for that? Okay, now observe carefully. In the remove head, suppose if your size is equal to 0, that means I can say my circular single linked list is empty, and return the value, return the control. Suppose if it is not empty and tail is equal to tail dot next. So means what? If you have only one element is there means, so that element next field is pointing to the same element, right? In such cases, what you need to do? You have to remove that entry. Else, otherwise what will happen? Otherwise what will happen? Your tail dot next, your tail tends to next field will become, so tail tends to next is there, right? It's a next field, like this I'm taking. So after completion of this, anyway you have to decrement the size by 1 unit. Okay, so I will explain with the help of a small diagram. Observe carefully. So consider I have one single circular single linked list is there in this style. This is nothing but node 1, and the next node is nothing but this one. Okay, and the next node is nothing but I have like this, and the next node is nothing but I have like this. So its next field is pointing to the beginning, right? So which one will become tail? This node will become tail node. Now consider another case is what? I have only one node is there, so its next field is pointing to the same, so this will become tail. Consider the data is 100. First case, if size is equal to 0, then single linked list is empty. If a tail is equal to tail tends to next, my tail is tail tends to next, right? Then we are making this a tail to point to null, which says that empty list. Otherwise, that means this case. So tail is equal to tail tends to next. If it is the case, this is the thing. Otherwise, tail tends to next is there, right? Okay, which will become, so tail tends to next. That means tail tends to next is nothing but this one. Its next field is this one. So this one will become, so tail dot next. Okay, so now we are making this link to point to this one, so that this link is gone. This link is gone, and by default this node is deleted. Now this is nothing but the circular list what we have. Okay, this is nothing but how to delete the element from head node. Can you please confirm, is this remove head? Is it clear for you people? Is the first method, is it clear for you people, friends? Please confirm. Anyway, I'm not going to execute now. After that we will see. Okay, right, sir. Now see here, Next one. So remove tail, remove tail. Now see what will happen. So if your size is equal to 0, okay, if your size is equal to 0, then what is the meaning? My circular linked list is empty. I am printing circular single linked list is empty and immediately return. Sir, if this one is not satisfied, then if a tail is equal to tail dot next, means what? We have only one node is there. So in such a cases, a tail will become null. Else, if it is not the case, here the cinema is going to be happen. Very, very important case we have to do. Okay. And after this, we need to make size minus max. Sir, what is this case? You need to take a temporary node. Okay. That temporary node is head, right? Here, how we are pointing head? Tail tends to next. Tail tends to next. Let us take a parallel example. Okay. So like this, we have one and its next field is nothing but this one, and this next field is nothing but this one, and this next field will become this one. We need to remove this node, right? This is our target now. Now listen carefully. So this one will become tail. Now I am making so one temporary node which is pointing to tail tends to next. That means this will become which node now? Temporary node, right? Sir, next after this. So while temp tends to next is not equal to tail node, till to reach the tail node, I am keep on doing. So temp is equal to temp dot next. Sir, is it a tail node? No. Then your temp will become this one. Is it a tail node? No. Then your temp will become this one. Sir, next node is tail node? Yes. Then it will stop here. Come out from this while loop. Sir, after coming out from this while loop, your temp dot next field will become tail dot next field. Okay. Sir, my temp dot next field will become so tail dot next. That means this one. Okay, right. What is the next one? You have to change the tail also, right? Your tail will become temp. So that what will happen? This one will become tail. So means what? This reference is deleted. Anyway, this link also we have break, right? That's all. Okay. This is nothing but how you can able to do, sir. Okay. Sir, what is this functionality? This functionality is nothing but so circular linked list. Okay. So remove tail method. Okay. So I think it is very clear for you people, right? Any doubts, friends, up to this? Is it clear? Clear? Right. So you try to implement delete at a position. I will go with the deletion of element. Okay. Void. So delete element. So integer, I'm going to give the value. So with that value, we need to delete the element. But I need to check really whether first element got removed or not. What is that we have to call? So remove head. After removing head, if you print the output, what we are getting is nothing but sir head element. This first element will be gone. Let us run. Sir, one removed, right? Yes, perfect. Now I need to remove list data. So remove tail. I want to remove the last node. Anyway, first node already removed. So last node should be removed. Let me check. Yes, perfectly working. Okay. Now we have to write code for deleting the elements. Sir, as usual, if your size is equal to 0, then system dot out dot println of circular single linked list is empty, and then return. Sir, else what will happen? We are taking some special pointers like node. We need some temporary node. Okay. Otherwise, I will take previous node. Okay. Which will become tail. So next I need to take a current node. I need to take current node, which will become tail tends to next. Okay. Next, I need to maintain one more node called head, which will become tail tends to next. These many pointers are required. Okay. Now listen carefully. Why these many pointers? I will explain. Okay. First, I will execute I will write the instructions, then I will execute. Okay. So if current node. Okay. If a current node dot value is equal to the value which you are required to delete. Okay. If it is the case, again, if your current node, okay, if your current node is equal to, so current node dot next, that means if you have only one node, then what we have to do, your tail will become null. Otherwise what will happen? So your tail dot next will become, already we have seen this, so tail dot next to next, like this I am taking. And after completion of this, I think better to return from this. Sir, when this particular case is going to be happen, I need to demonstrate. Observe carefully. For example, consider I have only one node is there. Only one node is there. It is nothing but a 10, and this one will become tail node. So its next field is pointing to the same thing. Sir, current node dot value. So here we have assigned current is equal to tail tends to next. That means for this we have so many names are there. Previous is this one. So current is this one. Head is also this one. Okay. Now current node value 10. I want to delete a 10 on. Okay. Same, right? Then tail will become null. Then tail will become null. This got deleted. So now we have empty list. Okay. For example, I have two nodes are there. This is nothing but a 9, and its next field is nothing but a 10. Like this we have. Okay. Now its next field is pointing to this one, and this one will become what, sir? Tail node. And the data which I want to delete is a 10, and the previous will become tail. So this one is another name for this is nothing but a previous, and current node will become tail tends to next. Your head is also tail tends to next. Is current node dot value is equal to value? Is it current node value is the same? No, current node value is not the same. That means we have to apply some other approach. Okay. So when it is going to be happen, suppose consider here we have 10 is there. Okay. So here we have 11 is there. Let us consider like that. So if current node is equal to current node value is equal to value. Yes, current node value is equal to value. Then is current node is equal to current node dot next. So this is the current node. Next field is also same. No. Okay. Then what will happen? Tail tends to next will become tail tends to next. So tail tends to next is this one. Okay, same node. So tail tends to next will become this one. So by default, this will be gone. Like this we have. Okay. I think these two cases are clear for you, right? Please confirm. Clear, friends? Is these two cases are clear? Right. Now, suppose if the current node dot value is not equal, then what will happen? Okay. So I think anyway we have used return, right? We are not required to write else, directly we can write the code. Okay. So if size is 0, it will return automatically. Otherwise it is going to return like this. Now Sir, what is the next thing that we have to do? I need to take your previous will become current node. Okay, and your current node will become, so current node dot next. Okay, like this I'm pointing now. While your current node is not equal to head, your current node is not equal to head, and if a current node dot value is double equal to the value which you are searching, and one more if condition, if your current node is double equal to tail, then if current node is equal to tail, then your tail will become so previous. Okay, so this is nothing but what we have if condition. Otherwise, so what we have to do, so here itself you can take one more instruction, like previous dot next field will become current node dot next. I will explain, don't worry. And we are returning, suppose if current node value is not equal to this one, we have to interchange the, like previous will become current node, so your current node will become so current node dot next. Okay, this is nothing but end of while loop, and we have to return at the last. That's all. Now see what will happen. I will execute with the help of a small code. Observe carefully, friends. Suppose consider I have a list like this. Like this we have, and these are nothing but the links what we have, and this one will become which node? Tail node, right? Now consider I want to delete the item called 4. Fourth node I want to delete. Now otherwise, to get a clear clarity, let us take 3. I want to delete the node called 3. Now see what will happen. Okay, now sir, previous I think here we need to take some other notations, right? Have you observed? Previous will become tail, this one will become previous. Okay, current node will become tail tends to next, this will become current node. So head will become tail tends to next, and this one will become head itself. Okay, like this we have. Now observe carefully. So previous is equal to current, previous is equal to current. So this is the previous, right? Okay, now this one will become previous node. Observe carefully. Now current node will become current node tends to next. Now this will become current. Like this we are changing. Now while current node is not equal to head, is it a head? No. So till it is going to keep on searching till it reaches a head node, we are keep on continuing. Okay, if it reaches to head node means what? There is no data, simply return. So if it is not equal to head, is current node value is equal to value? No. Then is current node is equal to tail? So if it is reached to tail, then what will happen? So tail will become previous. No, it is not a tail. Then so previous tends to next will become current node next. Sir, previous tends to next. Okay, will become current node next. So I think previous will become this one. Okay, so previous tends to next term will become current node next field. Okay, right. Now so it will return, it will return means 1 second. No, sir, 1 second, sir, 1 second, something is wrong. Second, please wait. Right, while current node uh yeah, so while current node is not a previous will become current node, and current node is nothing but current node tends to next. I am getting confusion. So is it not equal to head, right? Yes, then it will enter into if condition. Is current node value 2, is it equal to this value? No. Then previous will become current node, previous will become current node, and current node will become current node tends to next. Like this we have. Then since it is a while loop, again it will repeat. Is current node is not equal to head, right? Yes. Is current node value is equal to the value which you want to delete? Yes. Now, if current node is equal to tail, no. Then, sir, if it is not there, previous tends to next. Previous tends to next will become current node next. That means this link we are going to get. Right? Then return, come out from this. Anyway, these two links got break, right? That means this won't be there. Okay. So I think you people got very clear clarity about this. Please confirm. Do you have any doubts up to this, friends? Please confirm. Clear? Now. So let's clear all these things and I need to check really whether it is working or not. What we have to do, let us remove all these things. So list dot remove, no, delete, right? So delete element, sir, something like 2. I want to delete the 2. Now what will happen? We have to get 1, 3, 4, 5, 6, right? Let us cross check. Yes, 2 got removed. Sir, let us delete 3. Is 3 got removed or not? Let us cross check. Yes, sir. And let us check for 4 also. Is it going to be removed or not? Yes, removed. Let us check 5 also. Is it removed or not? Perfect. Let us go for 6. Is it removed or not? Perfect. Let us remove for 1 first element. Is it working? Perfect. Suppose if you want to delete 11, that element is not there, right? I think same list will be there. This is the way how you can able to implement single list. And anyway, last one, just I want to talk about Boolean search operation. So integer, I'm going to provide the value. It is very simple, no need to talk. So temp is equal to tail. Okay, temp is equal to tail. So for integer, I is equal to 0, I less than size, you can write like this also, I plus plus. Every time if a temp dot value is equal to the value which you are searching, simply you can able to return true. So otherwise, if this condition is not satisfied, the temp will become temp tends to next. Anyway, we are not required to maintain another thing. That's why I'm doing like this. And at last return false since the result is not there. Now let us ask for search method. So system dot out dot println of. So list dot search of. Suppose I want to search for 1. What output we will get? It is going to return true because that element is existed. Suppose consider I want to search for 5. Is it there? Yes. Suppose I want to search for 54. Is it available? No. Okay, like this we have circular single linked list program is there, sir. Okay, I think how to work with circular single linked list, what applications I covered on this. So inserting an element at the beginning, inserting an element at the ending, inserting at a specific position, removing the element from the beginning, removing the element from end, deleting the element, and the search operation. Only I covered these 7, sir. Rest of the things you can try by yourself. Only thing is nothing but the basics I have provided. Okay, sir, clear up to this? Please confirm everyone. Is it clear? Clear? Right, sir. Now, so I need to go for circular double linked list. I want to go for circular double linked list. How it is going to work, we will see. Okay. now. So 7 p.m. So here I'm going to create one more class. So a new class I'm creating. What is the class name? Circular double linked list. Like this I'm creating now. So what we have to do, sir? So here I will create circular double linked list. List will become circular double linked list. Okay, anyway we have to write the basic formalities one by one. I will try to write, sir. Now listen carefully. The first one is nothing but, so I'm going to create node. So two pointers are required. One is nothing but a head node which is null, and the second one is nothing but a tail node which is nothing but null. And the integer size of this list will become 0, and we need to maintain a node class, right? In this node class, so we have data, and then node, we have next field is there. Since it is a double linked list, we have previous field is also there. Okay, now node integer value I am taking, node next field I am taking, node previous field I am taking. Okay, like this we have. So current value will become, so current value will become value, and the current node next will become next node, and the current node previous will become previous. Like this constructor is there. So this is nothing but node class. Sir, first I will write print function because that is very, very important, right? So print like something like traverse. If your size is equal to 0, if you don't have any elements, so system dot out dot println of circular double linked list is empty. Okay, like this I am taking and I am returning the value. Otherwise, node as usual, we have to take temp node, which is a pointing tail tends to next. That means what? First node. Okay. So while your temp is not equal to tail, while your temp is not equal to tail, so system dot out dot println of, not println, simply I will take print. So temp dot value I am printing. Okay. So followed by some arrow marks we need to take. So what about next one? Your temp will become, so temp tends to next. And one value is going to be missed, right? So last value. That's why I'm going to take a temp dot value. So let us cross check how it is going to work. Okay. Like this we have. So this node next field is nothing but this node. So this one previous is nothing but this node. This one next node is this one. This one previous node is this one. So next node is this one. Previous node is this one. And its next node is nothing but this one. And its previous node is nothing but this one. Like this we have. So consider 10 we have, 11 we have, 12 we have, and 13 we have. And this one will become which node, sir? Tail node. Okay, tail node. This one is nothing but tail node. Now I need to traverse. Is the size is equal to 0? No. Temp will become tail tends to next. This will become temp. So is it not equal to tail? Yes. Then temp tends to value 10. So next value temp is equal to temp tends to next. Now temp is nothing but this one. Is it equal to tail? No. Then 11 will be printed. So now temp is equal to temp tends to next. Is it equal to tail? No. Then print that value. Temp is equal to temp tends to next. Is it a tail? Yes. Come out from this loop and print temp tends to value, which is nothing but 13. Okay. Like this we can able to display, sir. So I hope you people got very clear clarity about this one. Can you please confirm, is this circular double linked list, so print function, is it clear for you people, guys? Okay, right. Anyway, you try to implement a search function for that. Okay, you try to implement search function for that. Just I will write code only for adding and removing. Okay. So void, so add head. How to add the node at beginning? So integer I have add value is there, so I need to insert this at very beginning. Sir, what is the condition that we have to take? Node, I'm creating a new node here itself. So new node of, so value, and the next field will become null. Next field is also null. Like this I'm taking. Okay. So if your size is 0, means what? There is no element in this circular double linked list. Then your tail will become, your head will become new node. Next, so new node dot next field will become new node only. So new node, so previous field will become new node only. Like this we have. Okay, new node tends to next field will become new node. New node tends to previous field will become new node only. Like this we have. Okay. Now, so what is the next thing? Suppose if it is not the case, then what we have to do? Very simple. New node dot next. Anyway, we are adding at the beginning, right? New node tends to next will become, so head node, and so new node tends to previous will become, so head tends to previous. Okay. Then so head dot previous will become new node. Once if you see the diagram, you will get clarity. Then your head will become like this we have. So next your head will become new node. That's all. Since a node got created, size investments, I will explain this with the help of diagram so that you can understand them. So consider we don't have any elements initially. My tail is nothing but null. Okay, we don't have any elements. So what will happen? I created a new node, so with a double linked list. So data is nothing but something like 10, and this will become new node. So is size is equal to 0? Yes. Tail will become this node and head will become this node. Okay. So next new node tends to next will become new node itself. So new node tends to previous node will become new node itself. Like this we have. Suppose already I have some nodes are there. Okay. Something like this I have. Some I have two nodes are there. Okay, let us consider 1 2 3, and its next field is nothing but this one previous, and its next field is nothing but this one, its previous field is nothing but this one, and next field and the previous field, and this one will become tail node, and this one will become head node. Compulsory you need to maintain 2 pointers. Okay. Now see what will happen. Observe carefully. Now I want to insert a new node. So insert at first, right? Definitely a new node will be inserted here only. The name of this node is nothing but a new node. Consider the data is nothing but 11. Listen carefully. New node tends to next will become head. New node tends to next will become head because this is the head, right? Then new node tends to previous will become head tends to previous. Head tends to previous is this link. It will be gone. New node tends to previous will become head tends to previous. That means this node. Okay, right? Then head tends to previous. This is the head, right? Head tends to previous. That means this value is pointing. We have deleted this link, right? So we are making this head tends to previous to new node. Okay, right? So new node is there, right? Its previous is there. That is nothing but this one. Its next field. Its next field is what? This one only, right? It will become new node. Okay. So I think how to write this. So new node tends to previous. New node tends to previous is nothing but this one. Its next field will become new node. Like this. That means this link is also broken. Okay. So once if you delete these two links, now automatically this will become, so which node? Head node. This is nothing but a head node. Now onwards it is not a head node. Okay. This is the way how you can able to add the element at a heading. So can you please confirm? Is it clear for you people, guys? In a circular double linked list, so add head. Is it clear? Please confirm, friends. right? Now, so now I want to add at last, sir. Okay, I want to add at last. So void add tail, add tail. So integer value I am taking. Node, new node is equal to, so new node of, so we need to take a value and then null and then null, like this we are taking. Okay, so if your size is equal to 0, what we have to do? Your head is equal to, your tail is equal to new node. Okay, so then new node tends to next will become new node only, because it is the only node we have, and the new node tends to, so previous will become new node itself. Suppose if this condition is failed, then what we have to do? So then what we have to do, sir? New node, last node, right? New node tends to next will become tail tends to next. That means what? First node. Okay, then new node tends to, so previous node will become, so which node? Tail node. That is the, okay, then so tail tends to next will become new node. Okay, then so new node dot next field is a pointing previous field will become new node, then your tail will become new node. That's all. At last we have to increment the size. So let us take one simple example. Suppose consider I have some node is there, like sorry, so consider it is nothing but a 1, and it is nothing but a 2, and it is nothing but a 3. I want to insert one new node. Okay, so its next field is nothing but this one, its previous field is nothing but this one, and this is nothing but my tail. And here I'm not talking about head, but let us make it this one as a head. Its next field is this, its previous field, its next field, its previous field. I want to create a new, here a new node will be created. So this one will become new node. Consider the data is 5. Now observe carefully. Anyway, size is not equal to 0. New node tends to next is equal to tail tends to next. Tail tends to next is this one. I am breaking this and I am making this one as pointing to this one. New node tends to previous is equal to tail. New node tends to previous is equal to tail, because we have breaked this link. That's why. Now, sir, tail tends to next. This is the tail, right? Its next field is nothing but a new node. Excellent. Now, new node tends to next. New node tends to next is what? Sir, this one, right? Its previous will become new node. Its previous will become new node. So that we are breaking this link also. Then, so new node will become your tail node. Like this, we have to insert at ending. Okay. So I think this one is also very clear for you, right? Can you please confirm? Do you have any doubts up to this? Clear, friends? Right. Now, so what is the next one here? We have to remove from the beginning. Okay, void. So remove head, first element we need to remove. And similarly, so void, so remove tail, we need to remove the tail method. Okay, these methods are sufficient. I will execute up to this. So initially, if you print listed data print, Actually, we don't have any elements, right? Hence, what will happen? Circular double linked list is empty. Now, so list dot add head. Okay. Otherwise, list dot add tail of 311. So list dot add tail of I want to take 322. So list dot add tail of, so I want to take 333. Now print these items. Print this. You can able to see. Yes, perfectly we got. Now I want to add at the beginning. So add head I am taking by taking 999. Is it added at the beginning or not? Let me check. Perfect. Okay. Add position you try to implement, sir. Okay. So I am talking about remove head. If your size of this double linked list is 0, then you can't able to remove. So just I am printing my circular double linked list is empty and then return stating we don't have any elements. Otherwise, we have to reduce the size. Okay. So we have to reduce the size. After reducing this size, if your size is equal to 0 means what? We have only one element is there. Okay. We have only one element is there. So then what will happen? That is the element that we have removed, right? So then your head will become null and your tail will become null and we have to return. Suppose if size is not equal to 0, so we have to create one temporary node which is nothing but head tends to next, and temp dot previous will become tail node, and tail dot next will become temp node, and your head will become temp. Like this we have. Now let us see how it is going to work. Now observe carefully. Suppose consider I have elements like this 1, and this one will become 2, and this one will become 3. So its next field is this one, its previous field is this one, its next field and its previous field, its next field and its previous field. Okay. And this one will become tail. So we have to remove head, right? So is size is equal to 0? No. So reduce the size. So 1 already size is 3. Now it will become 2. Is it equal to 0? No. Then temp is equal to head tends to next. This is nothing but head. So temp is equal to head tends to next. That means this will become temp node. Okay. This will become temp. Okay. So temp tends to previous. Temp tends to previous. That means this one is equal to tail. So that we remove this link. So tail tends to next. This is the tail, right? This is the tail, right? Its next field will become temp. That means we deleted this link also. So that by default, this node is gone and this will become head. Okay. Like this, we are going to take. Any doubts about removing the head? Please confirm. Is it clear, friends? Right, sir. Sir, 1 second, please wait. Right. Now see here. So if your size is equal to 0, if size is equal to 0, then system dot out dot println of my circular double linked list is empty. Okay, then we have to return else size minus minus. Again, if your size is equal to 0, then what we have to do? So your head will become null and your tail will become null, and no need to stay in this loop. Simply we can return. Otherwise, node, so temp is equal to tail tends to previous. Previously you have taken head tends to next, now tail tends to previous. And the temp dot next will become head node. Okay, and head dot previous will become so temp node, and the tail will become that temp. Nothing beyond that. Let me take one simple example. So consider I have some nodes are there like this. This is nothing but 1, and this one will become 2, and this one will become 3. I need to remove this. Its next field is this one. So its previous is nothing but this one. Its next is this one. Its previous is this one. Its next is this one. Its previous is this one. And this one will become which node, sir? Tail node. We have to remove this tail. Sir, how we are going to do? So size is 3. 3 minus 1 means 2. Is it equal to 0? No. Then temp will become tail tends to previous. This one will become temp. Now what we are doing? Temp tends to next will become head. This is the head node, right? So your temp tends to next will become head node. So which we are going to break this link at the same time this link. Head tends to previous. Head tends to previous is equal to temp. Head tends to previous will become temp. Okay, means what? This link got a break and this link got a break. Tail will become temp. This will become tail. So by default, this name is also gone. So like this, we can remove at the tail, sir. Okay, this is nothing but how we have. So clear up to this, please confirm. Clear, right? Please confirm, friends. Right, sir. So now let us cross check whether these are working properly or not. Okay, list dot. So I am taking print. Before that, list dot, not add head, list dot. So remove head. Is that head node will be removed or not? Yes, 999 got removed. So I want to remove tail node. So remove tail, remove tail. Is it going to remove the tail node or not? Yes. So this is the way how you can work with circular double linked list. Sir, I implemented only few functions, that is insertion and deletion alone. Remaining things you try to implement. Okay. So this is nothing but what we have about linked list. Okay. Sir, clear up to this. Please confirm everyone. Clear up to this. Right, sir. Anyway, our next topics will be hash table, and then we are going to talk about the stack data structure and then queue data structure. From Monday, we will discuss about this. So tomorrow class is there, right? Can you please guess what will be the tomorrow's topic? Do you remember? Yes. So string continuation is there. I think I don't know up to which we covered. So I think so. String tokenizer we have finished, right? Yes, string tokenizer we have finished. I think we need to talk about regular expressions and applications, regular expressions and applications, and we need to see the programs. Okay. Yes, last class for strings, correct. So we need to see the programs, regular expressions and applications, maybe some 30 to 40 minutes I will take. So after that, we are going to give more concentration on these 30 programs. Okay. So tomorrow, as usual, our class will be there at what time? Okay. So at 7:15, I will start 7:15 p.m. to, so maybe I will take up to 9:15. Okay. So tomorrow I won't end until the completion of Yeah, definitely tomorrow at any cost we need to finish 30 programs. Okay. So and then we will close because tomorrow will be the last class for springs. And anyway, Saturday, Sunday there won't be any sessions. And Monday freshly we will start with hash table or stack, something like that. Okay. Right. Okay, sir. I will upload these running notes within a few minutes. You can download. Thank you, guys.